Bismillahirrahmanirrahim. So this is the first class in introduction of this operating system course. Okay, and I see that most of the students, you have already studied with me the previous course of introduction to operating system, maybe in the last semester. Okay, so you already know about operating system. Okay, let's start with some questions. Can anyone tell me what is an operating system? Anyone? Software or hardware? Okay, so it's a software that is used on hardware. Okay, with hardware. Okay, good. So have you seen any operating system? Can you give me an example? Android. Anything else? Linux. Good. Windows. iOS. Okay, good. So why is operating system important? Okay, good. And who uses an operating system? Everyone is using an operating system, and we will see why. Okay, so first, what is an operating system, and have you seen one before? So yes, Windows 8, Windows 10, Windows 95, any version of Microsoft Windows, Macintosh, okay, Mac OS. So Macintosh is actually the computer, and Mac OS is the operating system that runs those computers. Okay, then you have Linux. Okay, one type of Linux is Red Hat Linux, and then there are many other form of Linux or Unix operating systems. Okay, so Linux is the open source version. Okay, and then there are different versions of the Linux and Unix operating system. You can see some of them. Okay, here. So do you see my slides? Yes. Okay, so why do we use an operating system? Because we need to interact with machines. Okay, let's say this is a machine that you can see, and over here what do you see is that this is just a hardware. Okay, if operating system is not there, you cannot interact with the machine. Tafaul. Okay, there will be no tafaul, and it will be like this. There will be nothing on the screen. If you move your mouse, nothing will happen. So what we want to do is that if we want to use this machine, then we will install operating system in the machine, and it will start working. You will see something on the screen. You can use your mouse, keyboard, and hard disk, etc. Everything will start working. So this is why we use an operating system. Similarly, you can see other examples of operating system. Okay, Macintosh, Windows operating system, etc. Can you tell me which operating system will be used on this phone? Android. Why? Because it's Samsung phone, and normally Samsung, they have Android operating system. Similarly, which operating system is this one? iOS. Yes, you know this. Okay, and this is a television screen, so we know that there are also some operating systems. For example, this one is the Samsung television. They have their own operating system. We know this is an operating system because you can see different applications which you can run on the screen. Okay, similarly, in cars we have operating systems, and these are the stereo systems, speakers or DAC systems in car. They have operating system. This is an example of Android operating system, which is installed as a media player. You can see there is music, maps, messaging, and YouTube or other playing software. Okay, this is the one from Toyota company. Okay, this is their multimedia system. You can see radio, TV, DVD, and different options. Finally, we know that many other devices they also have operating system. For example, the top one, you can see this is washing machine, okay, ghasala. And why do we know that it has an operating system? Because you can see there is the screen which has some output, and these are some buttons which actually provide input to this washing machine. Whenever you touch some button, then it does something inside, which means it changes some state of the washing machine, and maybe it changes the output, what you see. Like here you see 100, maybe they change to 200 or some other number and change the type of the program. Okay, so there is also this dial. Okay, you can change, for example, what type of washing do you want. This is the power button, and so on, the play button. Okay, so there is an operating system inside this washing machine. What is this? Can you tell me what do you see here in this picture? Yes? Yes, this is airplane. Yes, so you can see the interface. There are many buttons, screens, dials, levers, controls, different types. And what we see here is that there is also an operating system, because otherwise without an operating system you cannot manage an airplane. So what does operating system do for an airplane? Whenever you do some input, you provide some input to the airplane, touch some button, change some state of the airplane. So actually it does some processing inside and changes the thing of the airplane, so you can control it, you can land it, you can take it off, and so on. Okay, so this was the basic introduction to operating system, the general introduction. What is an operating system? Why do we use an operating system? Now this is chapter 1 from the book. Okay, and the book operating system concepts is there in your course. You can find it online, okay, in Blackboard, okay, the PDF form of the book. So the introduction, which is the first chapter of this book, and these are the objectives. The first objective is about the organization of computer system. What is the organization of computer system? It's the hardware. What is the hardware of a computer system, and how do we organize the different parts of the hardware into one single computer system, like the CPU, RAM, hard disk, keyboard, okay, mouse, all those things. How are they organized? How are they connected? How do they communicate with each other inside a computer system? Then the second part is about the operating system, or the software, which controls the hardware, and we will see different parts of the operating system. Then we will see the different types of computing environments, mainframe, mini computers, but this will be very brief in a single slide. And finally, I have removed the open source operating systems. We will discuss them throughout the course with different examples. So what is an operating system? One definition of operating system is that actually it is a program, it is a software that acts as an intermediary between a user of a computer and the computer hardware. What does that mean? So the hardware is something which I showed to you in the beginning of this lecture, which you can use, but if the operating system is not there, hardware itself is useless. So you need something, some software, and in general this software is the operating system, in order to operate the hardware of the computer system. Now the operating system goals. First thing is that the operating system executes user programs and makes solving user problems easier. Okay, what are user programs? We are going to see. And what type of problems? Can you give me an example of user problem that you solve using computer? An example? For what type of problems do you use a computer? I cannot hear you. Please come close to the mic. What?
How to print a document.
Okay, printing a document. Yes. Anything else? Which document? Yeah, so the first thing is you can type a document inside a computer. Okay, so you use the application program like MS Word or Notepad to write something. So writing some document itself is one problem, solving your problem, then printing the document. Then you have calculator, then you have internet. Okay, you use internet on the computer to solve your problem. You search something, you download something, all of these solve your problem. Then you use audio video calling, for example Skype on computer, that also solves your problem. Now can you give me example of user programs on a mobile phone? Any user program on any mobile phone?
Google Map.
Google Map, good. Anything else? Chrome, browser, right?
Yeah.
WhatsApp, Facebook, and even when you make a phone call, so there is an application, phone application, and then there is contacts. Okay, so when you click on the phone icon, you can call someone, that is an application. Then you can search in a contact, you can call a contact. All these are examples of user applications for mobile phones, right? So the operating system, the goal of the operating system is that the user can execute programs easily. Then another goal is that it's easy to use the computer system, the hardware. Without operating system, actually you cannot use hardware. And the third one is to use the hardware in an efficient manner. Okay, so the first one is the use of computer system, which contains hardware and other applications, software. We will see the components of computer system in the next slide. Okay, so there are different definitions of operating system. One definition is that it's the one program which is running at all times on the computer, and actually this is called the kernel of the operating system. Now if you remember from the past course of introduction to operating systems, the kernel is actually the main part of the operating system. It is very small in size, okay, but it contains the main part, how to control the hardware, the inputs, the outputs, the CPU, the RAM. All those information is stored in the kernel. It also contains some basic commands, for example, how to create a file, to copy a file, to change a directory. So these commands are there in the kernel of the operating system. So according to this definition, kernel is a program which is running in the computer all the time. Okay, everything else, if it is not a kernel, then you have two possibilities. It is some system program, okay, which is some other program than the kernel. This program is part of the operating system. For example, your network program, the program which connects to Wi-Fi, it's system program. The program which uses Bluetooth to transfer file, it's also a system program. The program which changes the color of the computer system, or the program which prints to a printer, all these, they are system programs. And then we discussed some application programs. I gave you the example of, like, for example, browser. Then you have also antivirus tools and many other programs which you use, for example, Microsoft Excel, Microsoft Word, PowerPoint. Okay, these are application programs. And we talk about the second definition of operating system is as a resource allocator. What are resources? Resources can be hardware, software, which are present inside your computer system. So the operating system actually manages these resources. It manages your CPU, it manages your other hardware, it manages your software, and which means that it manages your application programs. If many application programs, they are run at the same time, then how the application program will use the screen, how the application program will use the RAM and the CPU, etc. this is all controlled by the operating system. And then the last definition is about the control program. That operating system is a control program. It controls the execution of programs to prevent errors and the improper use of the computer. Why would error come? Because if many programs they work together, then there is a big chance that some program may control the CPU and they will not give the CPU to other programs, so it will result in some errors. Or maybe they want to take control of the computer and the other applications will not be able to use the computer. So the operating system is the control program for all the applications and all the hardware of the computer. Now these are different computing environments. Okay, you can see on the left side, this is a very big computer. In fact, this is a collection of hundreds or maybe thousands of computers or CPUs in a single system. We call this a single computer system, but it has lots of hardware. It has different types of RAMs, several terabytes of RAMs, and it has several terabytes or petabytes of hard disk. Okay, it has maybe thousands of processors and other things. This is called a mainframe computer. So where do we use mainframe computer? Can anyone tell me? Where? Companies, but not small companies, very big companies like banks. Okay, so banks, because they have maybe millions of users, they have accounts information for each user, so they use this computer system. That's the bank information. Then the second thing is like airline companies or other very big companies who have maybe thousands of employees for different types of problem solving, like for managing salaries, for accounts information, for keeping track of customers. Even the telecommunication companies, mobile companies, they might be using mainframe computers. On the right side you see mini computer, which is like the size of a fridge or maybe a small fridge, a big fridge, it depends. So mini computers, they are not as powerful as the mainframe, but still they are very powerful. They are better than the laptops and desktops, and they are also used in companies and government organizations, even in hospitals, for keeping record of the users. Okay, so these are mainframe and mini computers. Then what do operating systems do? Here is another example of a computing environment. Like you see a server and different clients. Example of client-server architecture we see in labs. In your computer labs, you can log into any client. You can sit on any machine, provide your username, password, and the computer will log in to you. How? Why is it possible? Because each of these clients, which is also called a workstation, each of the workstation, it connects to server, and the server contains the information for every student of your class or every student of the college. So any student who logged into any computer or workstation, the workstation checks the server. It asks if the user is there in the database of the server. If it is there, they will accept your request and will log you to the server actually. There is a URL which shows you the difference between server and workstation. You should read it. Okay, so computer system can have 4 components normally: the hardware, the operating system, the application programs, and the users. So hardware is the first component, and in software we can have operating system software, which contains system applications, and we can have application programs. The hardware contains anything like CPU, memory, IO devices, and the software that controls and coordinates the use of hardware in case you have various applications. And in general, there may be hundreds of applications that are running at the same time. Similarly, many users may be using operating system at the same time, like time sharing operating systems. Or time sharing is like if your server and many users, they connect to the server for downloading of information. Application programs, before we discuss the examples of word processors, similarly compilers, which you use to compile your programs in one language to some other language. Okay, you have database systems and you have video games, you have chats, you have movie players, audio players, okay, browsers, etc. These are different examples of application programs. Finally, about users, so you have different types of users. People are normal users, but even other machines can be users. For example, here you see that this client machine is a user to this server. Similarly, all those machines, they are users to the server machine, okay? And other computers can be users of each other, okay? So think about this. Let's say my computer is connecting to Google server, so my computer is a user for a Google server. Next is this diagram that explains those four components. So you can see that you have single computer hardware, you have one operating system, but inside that operating system you have a number of system and application programs, and then maybe there are different users using different programs at the same time. How is it possible? It is possible because you may have different terminals for the same computer, and these users, they connect to the computer with the help of terminals. So in detail, these are the important hardware components of a computer. Okay, so can you tell me, these are different types of hardware, which of this hardware is called the brain of the computer? Which of this is the brain of the computer? CPU or processor? Yes, excellent. So why is it called the brain of the computer? Because actually it is in CPU where all the processing of information takes place. If you run a program, it is run in the CPU. An operating system, it runs in the CPU. So CPU is responsible for running all the programs. Then you have main memory. In main memory, what you can see is that it is storage for running programs and current data. What are running programs? When you install a program into a computer system, actually it is stored in the secondary memory. After main memory, we have secondary memory. So when you copy or install a program into a computer, it is actually there in the secondary memory. It is stored permanently. Okay, if you delete it or uninstall it, then it will be removed. Otherwise, it will be there. So when you run a program, which means you double click on its icon or you write its name on command prompt, it will run a program. And running a program means that from the secondary storage, it will come to the main memory. Okay, and in main memory, we call the main memory also as the RAM. Random access memory. I explained this in the coming slides. And secondary storage, you store long-term programs which are there maybe forever, okay, and you store your data, your files, your contacts, all those information that make up your data. So the storage types of secondary storage, they include hard disk, CD, etc. So can you give me any other example of secondary storage? USB, flash, yes, good, okay. So these are different types of secondary storage. And sorry?
Floppies.
Floppies, good, okay. So have you seen any floppy?
No.
No, it's very old, huh? Now we don't use floppy, okay. So then you have input devices, output devices. Input devices are those which help you to communicate with the computer, for example keyboard or mouse, and output devices which help the computer to communicate with us, which means that they send data to the user. So it can be like screens or projectors which send the data to the user, or it can be like speakers, printers, all those things. Can anyone tell me if scanner is input device or output device?
Both of them.
Why both of them?
Can we?
Yes, explain. So if it scans only, then it is input, because input, it takes the output from paper and take it to the computer input. But if it has a printer, then it will give you output.
Yeah.
So sometimes scanners they have printers, some scanners they don't have a printer. Okay, so it can be only input or it can be both. Okay, but normally the scanner, just scanner, it is an input device. Okay, then this is about computer system organization. What you see here is different devices or different parts of computer, and the important thing here is that all of them, they are connected to one another using something which is called system bus. So actually system bus, what you see here is the lines which connect, for example, the CPU to all other devices, or the disk controller to the disks and to the memory and to the CPU and all other devices in the system. So these are different types of devices, and in the next slide I am going to explain that these devices, for each of these devices, like a printer, actually you have a controller. So for a printer you have print controller, for disks you have disk controller, then you have USB controller, keyboard controller, memory controller. Okay, so these controllers, what do they do? Whenever the CPU wants to connect to a device for sending some information or receiving some information, actually the CPU connects to the controller of the device, and the controller, it knows what to do. Maybe let's say in the example of memory controller, the CPU may need to send some data to memory, so it will ask the controller and give it the data. The controller will then control the access to the data, how to write something in main memory. And if CPU needs some information, so it will ask the controller, and the controller will ask the memory for that information, and it will give it back to the CPU. So a device controller is actually in charge of some type of device, and then the system bus, it provides access to the shared memory. Why is it called shared memory? Because there is single memory and all those devices, they use the same memory, so it is called the shared memory. Okay, so this slide number 19 here, it explains the computer system operation. How do they operate, the computer systems typically? So first you need to understand different parts of computer system, which I explained in the last slide. Okay, you have like hard disk, you have screen, you have CPU, etc. These are different parts, and the user may want to use anything, so for that purpose they will execute the applications. These applications may be on IO device. For example, your hard disk is an IO device, so the hard disk has some application, the user double clicks and the application comes to RAM, and the CPU can execute that application. Now it says that the IO devices and the CPU can execute concurrently. Can anyone tell me what is concurrently? So what is the definition of concurrently? It says that IO devices and CPU can execute concurrently. At the same time, yes, good. Okay, so maybe the hard disk is reading some file or saving some file, and the CPU is playing some video, or the CPU is busy, let's say, in downloading something from the internet, so they can execute concurrently. Now all IO devices we are talking about, so keyboard, mouse, okay, screen, hard disk, etc., they will execute concurrently at the same time without waiting for one another. Now an important point here is that each device controller has a local buffer. Can you tell me what is a buffer? Sorry? Okay, I don't hear you, but a buffer is actually small memory, okay, which is available for temporarily copying something or storing something. So in case of device controllers, different types of device controllers, they have a small buffer, which means a small memory. It may be a few kilobytes or a few megabytes. Why do we need buffer? Because without buffer, let's say there is a hard disk which wants to copy something to RAM, so it will take time because the device is very slow. So what the device will do, it will copy the thing to the buffer first, and from the buffer it will go to RAM quickly. Okay, so that's why we need buffer for transferring of data. So when you want to move data between the CPU and the device, actually you cannot move it directly, okay, you have to use buffer. Similarly, from main memory to the device, or from device to main memory, you will use buffer. Okay, so the device controller, it informs CPU that it has finished its operation by causing an interrupt, and we will study interrupt in the after a few slides. It will come what is meant by an interrupt, so I will explain it there. Okay, but the thing is that what we see here is that whenever the device controller wants to inform the CPU, it will generate an interrupt. So we have already seen that operating system is a resource controller. Here in this diagram you don't see an operating system. What you see is a CPU which controls all these devices, speakers, printers, modems, etc. These are controlled by the CPU. But who will control the CPU? So actually the operating system, it controls the CPU. It is the operating system which tells the CPU what to do at what time. Okay, so that's actually these different resources that you see, they are controlled by the CPU, and the CPU is controlled by the operating system. Now, in the course of Introduction to Operating System, you already learned about the system boot up process, bootstrap. Okay, what is bootstrap program? A bootstrap program is actually a program which starts the operating system and the rest of the system. So how does it work? Actually the bootstrap program is normally present in the firmware. Okay, what is firmware? Firmware is actually type of hardware which can store some software, and it is better than the hardware, because in hardware you can change the content of the software, you can change whatever is inside hardware. But the firmware is actually something that once you install some software in it, it will not change normally. You cannot change the software of a firmware. Through special program, you can change the firmware when you want to update. Example of firmware is actually the BIOS, basic input output system. It contains some programs which are run only when you start the computer. So the firmware will load the program and then you can use it. So the first thing is, when you load the bootstrap program from the firmware, it will initialize all aspects of the system. It loads the operating system kernel and then starts the execution. So it's the bootstrap program which is responsible for loading the operating system. So every computer has its own bootstrap program. Even if there is no operating system, the bootstrap program will start the computer, but then operating system is not available, it cannot do anything. Now these days you see that if you want to buy any computer online from website, or let's say from extra stores or from soup.com, normally they don't have Windows. What do they have is DOS operating system. DOS operating system is actually an old operating system in which there is no user interface except a command line. Just like what you did in your introduction to operating system course, there was a command line in which you give programs. So normally these days, if operating system, Windows operating system is not there, so you have DOS operating system, and you start into that, and after that you install Windows yourself. So after the kernel is loaded, it loads the rest of the operating system. Because I told you that the kernel is a small part of the operating system, okay, and this kernel it has some very basic functionality, but if you want to use the advanced functionality of the system, then actually the kernel will start that, and it depends, it starts into what. You can start into Windows, or you can start into maybe Linux, for example, if you have installed the Linux kernel. Now some services are provided outside of the kernel by system programs that are loaded into memory at boot time to become system processes. So can anyone tell me the difference between program and a process? No idea?
No.
Do you know any program? Yes? So everything that you have installed, these are programs, like PowerPoint is a program, Microsoft Word is a program. But when you run a program, it becomes a process in the operating system. So here you can see these are processes which are running in the operating system. For example, in Google Chrome you can see there are 40 processes. Microsoft PowerPoint, 2 processes. One process is for this slides, the other process is for screen. So these are different processes, and a program, when you execute it, it is called a process. So a process is actually loaded into memory. Okay. Similarly, operating system is a program, but when you start a computer system, this program is loaded into memory, it becomes a process. Okay. So that's the difference between a process and a program. Okay. So in a few slides before, I talked about interrupts, that whenever the device wants to communicate with the CPU or with any other device in the system, it needs to send an interrupt to the CPU to listen to the device. Okay, so that's why we call that operating system is interrupt driven, which means that every time, almost all the time, there are thousands of interrupt generated in 1 second, and the operating system is going to see which one to process. Okay, what is an interrupt? I thought that interrupt can be hardware or software. Okay, from hardware part or from software part. Hardware, I explained that, let's say there is some device which wants to send the data to RAM, so it will be sent using CPU. And for that, it needs the attention of the CPU. So the CPU will contact the device and send the data to the RAM. So how will it do? For that purpose, the device will generate an interrupt. Okay, and through interrupt, the CPU will know who is calling me, and the CPU will contact that device and will do the operation. And for that purpose, we have interrupt service routine. Okay, for every interrupt, we have an interrupt service routine. Let's say you interrupt me, you ask me a question, so for that interrupt I have to answer you. Another type of interrupt, you give me some information, then I will answer to that information. or maybe you want to tell me that the screen is not working. That's another type of interrupt. So I will do something else. So whenever you interrupt me, I will do something in response to the interrupt, and that is called the interrupt service routine, what I am doing. So the interrupt which is generated by the software, it is usually a monitor call or a system call. Okay, so using a system call, actually the application program, it does something by the CPU, and we will explain that. Now here is an example interrupt timeline. So we have two devices, one is CPU, one is IO device. CPU has two states. In one type of state, HALA, it can actually execute the process, okay, any user process. Let's say it's application, some application the user is executing. So the CPU is busy in executing the process. And the other type of activity the CPU can do is the interrupt processing. Okay, so two types of activities by the CPU. Similarly, we have IO device, and the IO device can also do two types of activity. Either it is busy in transferring the data from the device to the RAM, or from the RAM to the device, for example, or it is idle. What is meant by idle?
Have idea.
Sorry?
We don't have idea.
You don't have idea. Idle means farigh, not doing anything. Okay? When it is not doing anything, this is called idle. So the IO device, it may be idle, which means it is not doing anything, or it may be busy in transferring the data. So here in this example, you see that there is an IO device, and here it wants to have some IO request. Okay, so it sends a request to the CPU in the form of an interrupt. This is an interrupt. So before that interrupt, it was idle, not doing anything. Now it is transferring, so it has an interrupt of transferring the data. Okay, this IO device. So it starts transferring the data, and after some time the transfer is done. This is another event. When the transfer is done, so it sends an interrupt to the CPU that the transfer is finished. The CPU here, before it was executing the user process, after this interrupt, what does it do? It processes the IO. Okay, the transfer is done, so it's doing some data transfer now, and when the CPU is finished, it comes again to executing the user process. Similarly, after the transfer is done, the device becomes idle, and then there is another IO request from the device. It starts transferring the data, and when the transfer is done, again it sends an interrupt to the CPU. Now the CPU, which was executing the user program, it is interrupted, so now it processes the interrupt, and after finishing the interrupt, again it comes back to processing the user program or executing the user process, and at the same time the IO device is now idle. So this is an example interrupt timeline. Okay, after interrupt, we come to the definition of storage and some review of the notation. We see that storage consists of bits and bytes and words. So the basic unit of storage is actually a bit, which can be either 0 or 1. So a bit can store only one value, a 0 or a 1. So overall, the whole storage, whether it's RAM or whether it's hard disk or USB or CD drive, they all have the storage unit, which is the bit. So there may be many bits inside a storage unit, but when the computer wants to access the data, it does not use bit. It might be using byte or a word. Now in the beginning, byte was important, and every byte contains 8 bits, and even in our keyboard, the data, these keyboard keys, they are encoded as ASCII bytes. Okay, so one byte contains about normally 256 characters. So normal ASCII, basic keys, they contain 127 keys. The extended ASCII, they contain 256 types of data. Okay, so you should search that in the internet, what is the ASCII code. Now a byte is 8-bit. The other type of storage unit is word, which is very important these days. I mean, in the beginning it was byte, but now people talk about word. Why? Because the word is related to the computer architecture. So for example, if you have 16-bit computer, so each word would be equal to 16 bits, and 16 bits is actually 2 bytes. So for a 16-bit computer, one word is equal to 2 bytes. After that we had 32-bit computer, and 32-bit computer had 4 bytes, because 4 bytes are equal to 32 bits. And now these days we have 64-bit computers. So 64-bit computers means that one word for that computer is equal to 8 bytes, which is 64-bit. So these are different sizes of words. Now we see here that we have different units like kilobyte, megabyte, gigabyte, terabyte and petabyte as well. And can anyone tell me, for example, how much RAM is there in your computer?
1 tera.
Not tera, no, tera.
Giga.
How many? Yes, giga, but how many giga? Normally in computers,
4 or 8.
yes, 4 or 8 gigabyte of RAM. Okay, that's we talking about the main memory, which is RAM. It is normally 4 or 8 gigabyte these days. Okay, and what about the hard disk? How much capacity does the hard disk have?
Tera or giga?
How many giga, for example? Do you know?
64.
Well, in mobile phone, you have 64, 32, 16 gigabyte or maybe 128. Like iPhone 10, it has 128 and 256 gigabyte. Okay, iPhone 10. But in computers, normally we have 500 gigabyte or maybe 1 terabyte or 2 terabyte. Yesterday I was looking onto online computers on soap.com and extra.com. Okay, and I found that some computers they have 1 terabyte and some they have 2 terabyte of hard disks. Okay, so the hard disk size is in terabyte and the memory size, RAM size is in gigabyte. Okay, and in mainframe computers, supercomputers, you talk about petabytes. Okay, similarly in Google servers, for example, or Facebook server, they talk about petabytes or exabytes, very big units. Now the storage structure is such that you have 2 main types of storage. One is called the main memory, the other one is called the secondary storage or secondary memory. The main memory is also called random access memory or RAM. Why is it called random access? Can you explain to me? Or can you tell me something which is not random? Yes? Any idea? Can you tell me about random access memory? Okay, so let's say, yes? Yes? Do you know about tape drives?
No.
Okay, so here are tape drives, for example. I'm going to see a cassette. This is cassette tape disc. Okay, so cassette tape disc is something like this. Okay, and you know this, right?
Yes.
Yes. So here, this is not random access, because when you use cassette, so actually there is a head over here, and the head is reading what is in the cassette. Okay, so the cassette, this type is moving, and then this is the tape which is also coming like here, from here to here. So you can only read what is at the head of the cassette. If something is here, you cannot read it. Okay, so that is why when you read something, actually it is only possible when it comes to the head. Similarly, this floppy drive, you see, it will be only if something is under this head, you can read that, but you cannot read directly anything. So these type of media, they are called sequential access. Okay, they are sequential, not random. But if you think about RAM, then RAM is actually random access. Why? Because you can read any part of the memory without waiting for something. You can directly go to the memory location and read that. So this is called random access. Floppy drives and tape drives, they are actually sequential access, or maybe not random access. Tape drives are sequential access, and the floppy drives, they take some time to go to the track and then add it. Similarly, in hard disk, actually it takes some time to move the part which is reading the sector of the hard disk. So it is not random, it will take time, okay, to read something on the hard disk. So I repeat that main memory is random access. It can access any information at the same time. Hard disk, actually they are not exactly random access, they are faster than sequential access, but it will take some time to read any surface on the hard disk. And similarly, CD drives, there is also a laser reader head, so it takes some time to align to the CD drive to read the information beneath the laser head from the CD drive. So it is not random access. Okay, similarly, main memory is volatile. What is meant by volatile? Sorry? And volatile? Temporary. What is meant by temporary? Temporary means, so RAM is volatile, which means that if the power is on, it has electricity, it can store the data. But if the power goes off, it does not have electricity, so the data is not there. Okay, so if you try to restart the computer shuts down and restart, it means that the data is lost from the RAM. So if you are working on a document and because of some reason the computer shut down, so the data in the RAM is lost. Okay, so that is volatile. And the secondary storage like hard disk, they are not volatile, because even if the computer power is shut down or the electricity is not there, the data is permanently stored on the disk surface or the magnetic disk, so that is non-volatile. You restart the computer and you will still find your files and other data and programs in the hard disk. Okay, so hard disks are actually rigid metal or glass plates covered with magnetic recording material. So if you search like before hard disk, okay, hard disk drives, then you will see that actually okay, so these are different types of hard disk. Inside the hard disk there is a, you see, magnetic plater, and there is a head which moves this plater, so it takes some time to move this head, and whatever comes in this head is read by the this plater and stored and brought back to the RAM or CPU. Okay, so it has tracks and then sectors. Okay, and there is a disk controller. I talked to you before about the controller, that every device is a controller. So there is a disk controller which determines the interaction between the device and the computer. So in addition to hard disk, there is also solid state disks. Okay, what are solid state disks? So let me search solid state disks. Okay, so these are usually used on mobile phones, okay, and fast media drives. So they are very small in size, like this is maybe the size of a coin. Okay, you can see different, and these are solid state disks onto different motherboards and so on. Okay, so solid state disk you can see here, and this is hard disk. So solid state disks, they are very fast because they are just like RAM, for example. Okay, you can access them very quickly. And hard disk, they take time. Okay, So these are the differences between solid state device. They are faster, okay, they have no vibration or noise, and they are energy efficient, and they are expensive. Hard disks, they are cheaper, and they are available in several terabytes. Because solid state disks, they are expensive, so they are only available normally in gigabytes. Okay. So solid state disks, because they are very efficient, so they are becoming more popular, but they are expensive right now. Okay. So storage hierarchy, very quickly I will just cover a couple of slides, and then we will stop for break, or maybe we stop. I will just take the attendance and we will stop. Okay, we will finish the lecture. So storage hierarchy in general, because we have different types of storage devices. Okay, so we organize this into the hierarchy based upon the speed of the storage, the cost of the storage, and the volatility of the storage. For example, this hierarchy shows the storage from registers, cache, main memory, solid state disk, hard disk, optical disk, and magnetic tapes in some order. So here on the top, the register, the size of the registers is very small. Okay, the size of the register is according to the word size of the architecture. So a 64-bit computer will have registers of 64-bit normally. Okay, and then a 32-bit computer will have small registers of 32-bit size. After the registers, we have cache. So cache memory, normally they are in kilobytes or maybe few megabytes only, 3 megabytes, 5 megabytes, 8 megabytes, like this, cache memory. Bigger than cache memory is the main memory, which are usually in gigabytes. Then you have solid state disks, which are in gigabytes but bigger, for example 256 gigabytes, let's say. Then you have hard disks, which are usually in 500 gigabytes or terabytes, 1 terabyte, 2 terabytes. Finally, you have optical disks. Normally now the optical disks, they are 5 gigabyte, okay, or 2 gigabytes, something like this. But the optical disks, they are no longer used. People don't use, because instead of optical disks, you have USB, which also contains solid state disks. And finally, you have magnetic tapes, which are also in terabytes. Okay. Now the thing is, which of them is the fastest in your opinion, and which of them is the slowest? Flash memory is what? So this is actually this is flash memory, this here. So it is between them. But which one of them is fastest? The registers are fastest, or the magnetic tapes are the fastest? Yeah, these are the fastest of all. Then the cache, it is slower than the fastest, the registers, but faster than all the other devices. Then main memory, then solid state disk, then the hard disk, then the optical disk, and finally magnetic tapes. They are the slowest of all of them. Okay. Now tell me which one of them are the most expensive. Ghali Saab, which one? Registers are the most expensive. They are very small in size, but they are very, very expensive. Okay, because the material they are made from is very expensive. Then cache is a little bit less expensive. Then main memory, and the least expensive, okay, the cheapest one is the magnetic tapes. Okay, so we stop here in caching. Inshallah, we will start caching after next week. So Monday is no class, right? Because it is holiday.
Yeah.
So inshallah, next Wednesday we will resume with storage device hierarchy and caching.